All right, ladies and gentlemen. 10.6, we are putting everything together. We're going to take all four conic sections, the parabola, the ellipse, the circle, and the hyperbola, and we're going to figure out which one's which, and we're going to work on graphing them. So, first off, let's take a look at the actual conic sections. Conic section does come from a double-sided cone, and the way you get these is if you take that double-sided cone and you slice it on an angle. You can see here that's your parabola. If you slice it so it's parallel with the top and bottom, that's your circle. Slice it all the way through a cone on an angle, that would be your ellipse. And if you slice it straight up and down through both cones, that's where the hyperbola comes from. This box here, this is a refresher of your standard forms of the equation. So we have the parabola, we have the circle, we have the ellipse, and we have the hyperbola. Today we're going to take a big look at the standard form or the general form and converting back and forth between the two. So the general form is going to look something like this. It's going to look big and it's going to look ugly. Ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, where a, b, and c are not all 0. So there can be 1 or 2 0, but they're not all 0. Now, simply looking at this equation, we can figure out which type of conic section that we have. So, for instance, if A is 0 or C is 0, so A or C, one or the other, but not both is 0, that's your parabola. If A equals C, that's your circle. If A and C have the same sign, and A does not equal C. So if they're both positive or both negative and they're different numbers, that's your ellipse. And finally, if A and C have opposite signs, that is your hyperbola. Alright? So let's take a look at what we have here in the first problem. Without writing the equation in standard form, state whether the graph of 3y squared minus x squared minus 9 equals 0 is a parabola, circle, ellipse, or hyperbola. So the thing you're looking for is the x squared and the y squared. If they're both there, the parabola's out. So I know it's not a parabola. Next one, circle. In order for it to be a circle, the coefficient in front of the square terms have to be the same. They're not. That's out. Which means you're now down to a hyperbola or an ellipse. An ellipse occurs if this value and this value, the numbers in front of x squared and y squared, have the same sign. It's a hyperbola if they're opposite. And in this case, since y squared has a positive 3, x squared has a negative 1, they have opposite signs, which means the big winner here is the hyperbola. Alright, number 2, without writing the equation in standard form, state whether the graph of 2x squared plus 2y squared plus 16x minus 20y equals negative 32 is a parabola, circle, ellipse, or hyperbola. Again, I find the squares. X squared and y squared. Both there, not a parabola. 2, 2. Both of these values are the same number. If that is exactly the same number, that means we have a circle. Same question. This time, equation y squared minus 2x minus 4y plus 10 equals 0. As I analyze this equation, I notice, hey, there's a y squared, but where's my x squared? There is no x squared. If you only have one square means the other one is 0, which means this has to be a parabola. Without writing the equation in standard form, figure out whether 2y squared minus x squared plus 16 equals 0 is a parabola, circle, ellipse, or hyperbola. Again, I see both squares here, not a parabola. Different values, not a circle. Positive 2, negative 1, different signs equals hyperbola. Same question, 3x squared plus y squared plus 15x minus 21y equals negative 11. X squared, y squared, both there, not a parabola. 3, positive 1, not a circle. Positive 3, positive 1. Different numbers, same sign. Different numbers, same sign means ellipse. All right, now here's the tough part. They're going to give me the equation in standard form, or sorry, in general form. They now want me to write this in standard form and figure out whether it is a parabola, circle, ellipse, hyperbola, and graph the given equation. So let me pull up some graph paper first off. Okay, here's my graph paper. First thing, let's try to get this into, figure out which one we're looking at. So if I take what I have, let's put it all on one side. 2x squared plus y squared minus 18 equals 0. Now, why did I put it all on one side? Well, I put it all on one side so I can look at the x squared and the y squared together. So first off, x squared, y squared together, not a parabola, that's out. Positive 2, positive 1, not a circle, that's out. Positive, positive means this has to be an ellipse, so I'm graphing an ellipse. Once I know what it looks like, now I can put it in the form that I like. And the form that I like is when x squared and y squared are on the same side, and it's equal to 1. So let's add the 18 to the other side, and now I can divide by 18. And when I divide by 18, this gives me x squared over 9 plus y squared over 18 equal to 1. Once this in this nice standard form that I like, now I can get all my given information. X squared, y squared means center is at 0, 0. The bigger value here is y, which means this has to be a vertical ellipse. So this number is b squared, which means b has to be 3. This number then becomes a squared, which is the square root of 18. So when I graph this, a represents how far up I go, since it's under the y. So square root of 18, a little bit bigger than 4, not quite 5. So right about there. Same thing down. Right about there. The b is my 3, so that's how far in the minor axis that I go. So 3 units this way, 3 units this way. And the one extra thing that I need c, the foci. And remember, c squared we find by taking a squared minus b squared. A squared minus b squared is 18 minus 9. Keep in mind, this is b squared, this is a squared. A is always the bigger number in the ellipse, which means c squared is 9 and c has to be 3. So the foci are located 3 units away from your center. There and there. And I can now draw my ellipse. Get out my handy dandy ellipse tool. Looks pretty close there. Slide it over. A little bit short. Let's see if I can extend this. There we go. And there's our ellipse. Alright, let's give one more of these a try. X squared plus y squared minus 6x minus 7 equals 0. I want to try to figure out what this is. First off, so x squared, y squared, not a parabola. Positive 1, positive 1. Ooh, same number means not an ellipse, not a hyperbola. Got to be a circle. Now, once I know it's a circle, now I try to make it look like a circle. And the big thing I notice here is there's an x squared and there's an x, which means we are completing the square. X squared minus 6x. Remember, to complete the square, we take the b term, divide it by 2, and square it. So 6 divided by 2 gives me 3. Square it, we get 9. And remember, if you add 9 to one side, you have to add 9 to the other side as well. So finishing off my equation, I then have plus y squared minus 7. Now, the whole reason for completing the square is these three terms are now going to factor, and they factor nicely into x minus 3 squared plus the y squared, which I bring down. The number 7, I'm going to add that to the other side, which gives me a 16 over here. And if you remember back from circles, this then means your center is located at a positive 3, 0, and your radius is located at the square root of this number, which is 4. So, if we draw our circle, we're going to start at 3, 0, which would be here. And radius of 4 means I'll go up 4, I'll go left 4, I'll go down 4, and I'll go right 4. And from there, we make our circle. And that is conic sections. Have a good night. We'll see you tomorrow during class.